All right. Good evening, everyone. My name is Yelena. I'm one of the faculties at University of Maryland Global Campus in Data Analytics program. So the purpose of tonight's session is to help you get started with using R and RStudio. So here is the agenda for tonight. We're going to talk what is R and what is RStudio. We're going to talk about the RStudio environment interface. We're going to talk about how to create and save the R script, how to use variables, how to read data from the CSV file, data frame properties, descriptive statistics, and etc. Data visualization. And of course, there will be some time for questions. All right. So for the purpose of the demonstration, here is the data that we're going to use today. The data is on employee. See here, it has job satisfaction, the last evaluation, number of years since last evaluation, right? So number of projects the person was on, right? And etc. Some employment information such as average monthly hours, okay? And that's important one, whether an employee left the company or stayed, right? The person's salary and person department. That's the data that we're going to be looking at the second part of the presentation. Now, but before we do that, first of all, what is R and what are the advantages of R? So R is a language for statistical analysis, right? It's open source and you don't need to pay for it, it's just free. It works very well in the academic settings. It implements some advanced statistical methods. Then the good part is that it's also reproducible. You can save your sequence of commands in the file. And if you have to reproduce the work, you just rerun the file. R is continuously growing. So as we speak right now, new packages get developed, right? So also you can use R with databases and it supports parallel processing. But does R solve all problems? Of course not, right? It does not solve all of the problems. Standalone R does not have a graphical user interface, and you need to put some effort into practice and learn. R is case sensitive, remember that, right? Then you need to keep on updating your packages regularly. The good thing is that updates are undergoing, it's growing, but you have to make sure that you're working with the latest version, right? Then in order to install R and RStudio, you must have the local admin rights on the PC, or you should be able, it will prompt you to enter admin password, admin username and password, you need to have it, right? Now, another drawback of R is that you cannot embed it into the web applications, okay? Because it lacks basic security. And the performance is slower than Java or Python. Just that. Now, so what do you need to install if you have not already? You have to install R version for Windows or for Mac, whichever system you're using. And then you also need to install the desktop RStudio version, the desktop, and you want to get the latest. So the latest one is 4.2.0. That's the latest version, right? Now, remember this. If you try to download RStudio without R installed, you're going to get an error. So you must install R first and then RStudio, okay? Now, we're going to talk about a little bit about the interface, right? RStudio has a little bit more graphical interface than R is. It's an integrated development environment, and it supports direct code execution. Images tab comment in the console window, and I'll show you what that is, right? And see, the thing is, remember this, you can use R without RStudio, but RStudio may not be used without R, right? Remember that part. So now, let's take a look at this. So this is the RStudio. When you install it, this is approximately how it's going to look like. You have this console window. Console window is a window where you may run the commands. But remember, anything that you run in the console window, it's not saved in a file. That's not reproducible, right? But take a look at this. For example, if I run the version command, it's going to give me the R versions that I'm currently have installed, right? And the day and month when this version was released, right? So the console window is where I see when I can type my command, or my commands will be echoed. And I'm gonna see the output in here. And also I'm gonna see any error messages, right? I'm gonna see any error messages in here. And any warnings, any informative messages. Some messages are informative. Right? At the top, what do I have at the top? I have this environment, right? Oops. Guys, please try to turn off if you're using the visual video camera, the video, please try to turn off because it's taking extra bandwidth. All right, so I hope you can see my screen. Can you see my screen?
No.
No. Okay, I'm gonna start sharing again. When did you stop seeing my screen? Just now?
Yes.
Okay, I'm gonna go back. I'm gonna share it again. Okay, share screen. Okay. Sorry guys, share. Okay. Now, so here this is an RStudio, right? And I'm gonna share RStudio again. So what I was talking about is this. In this window, this is our console window, right? Where that's where you see output, error messages, and messages and warnings. Here in this window, this is an environment. Environment window shows what you currently have in your memory, right? In our working in the working memory. History is a commands history. Like you see, I just ran the history command, and I can just go here, click to console, and I rerun the command that I just ran, right? So this is history. Don't worry about the connection, okay? Don't worry about this part. We're not connecting to the database in here. Tutorial, if you wanted to, you can install Learn R package, right? And I'll talk about packages. And this is just something that you might use to practice, to learn more, right? So now here, well, files is going to show you files in the current working directory. And working directory is where R looks by default. Like if you're trying to open a file or if you're trying to, let's say, read the data, right? It will think that your file is located in a working directory. It's working directory files. Okay. Plots is where you see the visualizations. Packages, we're going to talk about it more, but the package is just it's a collection of it's a grouping of predefined functions. And sometimes it can contain the data sets, it could contain the VNet, right? It could contain multiple things like documentation, right? We're going to look at that too. Help, this is where you can read about different help topics. Like, for example, if I want to read about more about the bar plot, I just put the question mark, right, and put bar plot. That's one way to look for help. And notice that as I'm typing, right, I get a drop down here, so I can select. Okay, so this is a help page for that, for the bar plot. Don't worry about that right now. Now, to make sure that your work is reproducible, especially for the assignments, and to make sure that you can turn it in, what you need to do is this. You're going to do file, and you're going to do new file, and you're going to do the R script, right? That it will open the blank window, and this is where you would type your commands that you're going to turn in for assignment 1. And then you're going to save that, right? Always keep saving the work. And when you save the file, it's going to have what? .r extension, right? But for you, what I did was I prepared already the code for tonight's session. So let's do this file. You can do open file and find where you saved the file, but I'm going to show you a little shortcut. If you had a file recently open, you can do recent files. See this? Those are the files that you had recently opened. I had this file recently opened. This is a file that I'm going to give you. You're going to have a copy of this file after this presentation, right? Let's see. I usually going to do as a demo, but sometimes I use slides as well. But what we talked about here, this is how you would create the script, R script, and you want to save all of your commands, okay, in the script. Now I'm going to talk about how to run the R script. So here, this is called the source window. And this is what the R script. To run it, you're just gonna put the cursor on a command and click run. You're gonna put the cursor on the command and click run. Now, what is this here? This means that this line is a comment. Comment is a non-executable line of code, right? It does not reproduce the output, but it's rather useful for documenting the code. So that way, tomorrow when you have to take that code and modify, you're gonna remember what that code does. Or if I give you this file, it's gonna be easier for you to see what the code does, right? Another good thing about R is that there is more than one way to produce the same output, if you will. So, like for example, r.version and version, those two commands are going to return the current R version. And then session info also has an information on the R version, right? It has more than the R version. It also includes the operating system version and etc., right? And here, those are the packages, right? The group of functions that are already in memory, right? Now, system time is going to give you the current time. ls command is going to return you the object that you currently have in memory. At the moment, we don't have anything, right? So object is the same. It's going to also return the object that you have in memory. At the moment, we don't have anything, right? Here, data is going to list the pre-installed data sets. So it's going to show you the data sets. In the package, there is a package called data sets, and that's where your iris data comes from. And you're going to see the first exercise, and also you're going to see some quiz questions on the iris data in upcoming weeks. I believe there is something in decision tree week. There are some questions in the quiz on iris data. That's one of the, it's a pre-installed data set. Okay. Now, here you may use R as a calculator. If you have R around, you know calculator perhaps, right? 5 plus 9 equals 14. Now pay attention, do you see the subscript 1? Well, the reason is everything in R is a vector. Over here, 14, this is a vector of a single element. Number 1 means that this element, number 14, is located at position number 1. Okay, it's located at position number 1. And the elements of a vector are numbered starting from 1. Okay, elements are numbered starting from 1. Now, what you could also do, this is the print command. It's going to just say, welcome to data mining, right? Now, well, I did some calculation, 5 plus 9, but I still don't have anything in my environment. It's because I have not assigned anything, right? So now what I'll do, I'm going to create X and I'm going to assign the 3. Okay, so this is less than sign, right? And this is an assignment operator in R. So I created X is numeric, and I assigned the value 3 to an X, right? That's what it shows now. And if I want to output X, I can do print X, or I can do just X. Here, you may embed the commands. What this does is it's going to create a variable Y, and it's going to assign 5 to Y, and it's also going to output what Y is, right? So let's see. So here, this command here in one line, it's the same thing that I'm doing here in 2 lines, okay? And now suppose that I no longer need X. RM command lets you remove objects from the memory. RMX is going to remove X, right? And this one, what that will do is this. ls command, remember, ls returns everything that you have in the memory right now. So what I'm doing here is I'm going through the list of what I have in the memory, and I'm going to remove all of them. So this is how you would remove everything that's in your memory. Options command is going to show you any options. Like, for example, suppose that your output is long, how many characters to show perhaps before it cuts off, right? Well, there are numerous options that you can look at your leisure. Okay, now next thing is, this is how you clear the screen. This is similar to Control L, right? So this is how you would clear this console window. Def off, well, it's not gonna work when I run it at the moment because I have not done anything with plots, but it would clear the plot settings. History, it's gonna show me the last 5 commands on the history. So here is my history. Those are the last 5 commands, right? And if I wanted to rerun this, I can just click here and I'm gonna do to console, and this is how I rerun, okay? This is how I rerun the commands that I already ran. Now, this part, it may seem easy, but it's gonna be used as part of the more complex command. So command C is also known as a combine command. What this will do is it's gonna create it outputs a vector of 5 elements, 1 through 5. It will not be stored anywhere in this case because I'm not assigning. There is no assignment here. So just do this output, 5 elements. And see the subscript 1, it means that the first element in this row of output started position 1. It does not mean that this vector contains one element, okay? It does not mean that. Now, here there is a little shortcut here. To generate 1 through 5, I can do 1 colon 5, right? If I don't want to list all of them. But another difference, what I'm doing here is that I want to assign this to X, right? This will create X and assign to X. And here we display the value of X. Now here, you see this X is uppercase. If I was going to put lowercase instead, right, now I'm gonna get an error. See this object X is not found. It's because R is case sensitive, right? So in here, what I did was I outputted X. But suppose that my X had 1000 elements. I only need the third element. So what you do is you specify the element number in the brackets. This will output if I run this, I expect it to output only the third element, right? Element at position 3. Class of X is going to give me the data types, and type of return the same command, reset the same output. I would like you to have both because it depends on what book you read. You may see differently. Okay, so does it list always starting at position 1? Yes, only in the first row. We're gonna see the output that spans across multiple rows. So in each row, it's gonna be an element ID that starts the row. You will see it. Okay, I hope I answered the question. But we're going to see it as we keep going here, right? So when the output spans across 2 rows, the element that you're gonna see in the subscript, it's going to be the index of the first element in the row. We're gonna get to it shortly, but here str just shows the data structure, right? It's a vector of 5 elements. Now here, this is what, if you want to create the vector and you want to have numbers 1 through 5 and then 8 through 10. This is one way to do it, right? So you do 1 through 5, comma, 8 through 10, right? Okay, and I just ran the output and I just ran it, right, with a summand operator, and this is our Y. Now, if I want to output only elements 3 to 6, this is how I do that, right? Then I can show class of by, it's going to be an integer. Str shows the structure. What I could also do is if I do multiply by 2, I'm multiplying all elements of y by 2 and output just to see. So you run this just to verify that all elements are multiplied by 2. Next topic is going to be the sequences, right? Most of you are familiar with the sequence is. So here, this will create a sequence of 10 elements, but because I don't specify what to start from, it's going to start from 1 and increment by 1. So let's go ahead. Let's try that, right? So Z is a sequence, 1 through 10. W is going to be another sequence, but here I want to specify the start. The start is going to be 2, and I want to go until 10, but I don't specify the increment. It means that it's going to go it's gonna increment by 1, right? So let's output. You see that, right? It's gonna increment by 1, but see, I'm missing 1 because I wanted to start from 2. Here, this is different. I want to start from 2, but I also want to increment by 2, right? And I'm gonna output it. So that's what I'm getting, right? Now this one, well, this is important because this is gonna get you the long way, okay, to get how to get help. For example, I want to know what my bar plot command does. I'm just gonna run this question mark or bar plot, right? Question mark and command name. Alternatively, I can put help and a command name in parentheses. It's gonna do the same. So what do you see here? This is a package where the bar plot is defined. So package is what? Set of functions, right? Here, it's telling me the input parameters that the bar plot function could take, right? The arguments. It is an explanation of the arguments, right? And there are some examples too that I can run and check, right? Titanic is one of the pre-installed data sets, yeah. So you can run these examples to check at your leisure, right? But suppose that I don't know how to spell the bar plot correctly. I know that it starts with letter bar, but I don't know if it's PLOT or is it PLAT? Just suppose that I don't know. So what you do is you can run a propose command, and it will display now the commands that contain bar. See this? So now I found what I need, right? So that command is gonna show me the function, right? What I can look help for that contain bar. And this one is just will display a set of example on command usage, right? I'll let you explore at your leisure. What this will do is it will search for online documentation on a package, right? It's gonna open the browser, whatever you have set as default, and it's gonna open the search. You see what it's opening up the browser, and it's gonna open the information about the package in the browser. It's just giving you the alternative ways to look for help, right? Okay, so I'm gonna close this out. And the packages we're using are from CRAN repository, okay? Now, in your first exercise on iris data, the data set was pre-installed, right? But what if you want to analyze data that is not pre-installed with R? Well, you need to read data into R. On my hard drive, I have the folders that I call data sets. And in that folder, I saved some files, right, for this demo. I saved the HR file that we were talking about, the data I showed you earlier, HR data. Okay, so what we're gonna do now is we're gonna read the data into R, right? But first thing, what we need to do is we need to set the working directory. Working directory is a location where R looks for by default to read the file. So set WD is going to set the working directory. Let me run this command. And suppose that you're not sure if the command works, how do we verify it? We run get WD command. That command is going to tell us what our current working directory is. In addition, if you look at the title bar here of the console window, it also shows the directories that you're currently in, current working directory. It shows you here, right? Now, this command lets you list the files inside your directory. So I know that HR data that I'm going to use is in here, right? And those are the data sets for your other exercises. But here we're going to use today HR data.csv, right? So now what I need to do, I know that this, well, sometimes if you misspell the file, that's another useful command. You want to check if the file exists. It does. Now I'm ready to read my data. So what I do is the command is read.csv. Here is the file name. Header equals true. It means that the first row in my data file contains column heading. I want to read the column headings, right? Into the I want to read the first row of the data frame should be column headings. And yes, I just realized that I forgot to tell you this. Take a look at this. Take a look at this. See this output here? This one is 1. This one is 5 because this row starts with element at position 5. 1, 2, 3, 4, 5. See, that's why it's 5, right? This is a 9 because this is a 9th element. See, here now we have example where the output spans across multiple rows. See, this 1, 5, right? But it could be slightly different depending on how you resize, because these panels are resizable, right? And output here wraps based on this window size. Okay, so now, well, let's read this here up. And this one, comma, it means that the file is comma delimited. As is equal false. It's because some of the columns contain the sort of like a string data. I don't want that to be read as a string, right? I don't want that to be read as a character data. I want this to be read as a factor data. Well, some data in here, right? I will have to show you. But if you don't put as is equal false, some of your data will be read incorrectly, okay? You want your character data here. In this case, we are not analyzing text. You want the character to be read as a factor, okay? Now, let's read this data. Okay. Now, if you notice that here in the environment, oh, did I stop sharing again? Share screen, share, right? Okay. No, it's because the environment button is very close to stop share. That's why. Okay. So here it is. This is you can toggle between list view and the grid view, right? So this is my environment. Okay, so this is what HR data frame, right? And I'll show you how to check this programmatically too. So this is a number of rows that I've read. Well, actually the number of rows in a file, it's going to be one more because the first row has a column names, right? And this is an observation. There are 10 columns in my data set. Here, it's showing me the column names and their data types. The department is a factor, right? And there are 10 levels. It means 10 distinct values. And the salary, in this case, it's high, low, and medium. But if I did not set this as is equal false, this would not read correctly. This would read as a character, all right? Now, this thing here, view HR, that will do the spreadsheet view. This is going to do the spreadsheet view of your data, okay? And you can sort it, etc. Now, head is going to display the first 6 row in a data file. It's going to output to console. Run. So head, the default is 6. Remember that, but I can change it. I can specify that I want 10, for example, right? Or tail command, it's going to show the last 6. Or I can specify to see the last 10, for example, right? So that's a preview, right? Next thing is that we can look at the data frame property. STR is going to show the structure, but this is somewhat similar to what you see right now in the environment window. But remember, you're not going to have windows all the time, right? So if you want to learn how to do this programmatically, and what this does is that see the sources as the 3 values, and it says here that the first row has a value as a second level, which is low. Here, the third row is a medium, right? 1, 2, 3 values. That's just how they write it. And here are the departments, right? This shows the structure. Here you can also check the class. The class should be data frame. And then here, this command to check is data frame. Okay, that's going to return true. Now, there are several ways to display the column names. You can do names or you can do col names. Am I answering quiz question? Okay, no. See this? And again, here, this is the index. See this salary here, this is a 10th element. You see this output, it's a vector. Everything in R is a vector. And the vector contains 10 column names, 10 elements. First, fourth, seventh, and 10th, right? Okay, or what I could do is I could change the window size, and to rerun the last command, you can just click the upper arrow. Upper arrow on the keyboard to rerun the last command. Do you see this? Now it's a little different because I increased the size of the window. See? So 1, 5, 9. It's because I increased the size and I show more in the same row. Okay. Now, next thing is, and I'm gonna give you this file after this session, so don't worry. Dim command, it's gonna show you the dimensions or number of rows, number of columns, right? Okay, so this is number of rows. But remember that in the actual, in a file that you're gonna get tonight as well, you have the first row are the column names, right? So there's gonna be one more row because column names plus the data rows. Now, if I want to see only the number of rows, I can do nrow command, or I can also do, see this dim, right? But remember, dim is the output is a vector. So the first element in that vector shows me number of rows, right? Here, number of columns, I can do ncol command. I can do length. It also returns the number of columns. Then I can take the same dim command, but I want to show the second element, right? And this is another way. Names, it's going to return the list of column names, and this is the length of the list of column names. Okay. Now, here, so str command returns the structure. Summary command is going to return the descriptive statistics. So let me run this. This is a summary command. And remember this, when you have the numerical, right, columns, you're gonna get the what it called is 6 number summary. Minimum, first quartile, median, mean, third quartile, and the maximum, right? Notice that there is no standard deviation here, right? It does not return standard deviation. Well, then another thing is that take a look at this. Well, salary, we know that it has 3 values, right? All 3 show here. But for the department, we know that we have more. Well, over here, I see only 6, right? I see 6 departments that have the highest number of people. The remaining departments are grouped under the category called others, right? That's what it does here. What I could do here is that I can do max sum. So max sum, this is gonna do, this is the input parameter. And what I specified is that I wanted to list the top 9 instead of, before it was showing me what top only 6, right? Top, yeah. But here it's gonna just show, it's gonna show me top 9, right? Because I specified that I want to see 9. Okay, now another thing to point out is that NAs, it means that somewhere this column has a missing value. NA stands for missing value, and we'll get to missing values. Then here, suppose that my data set has multiple columns, 1000 columns, and I only want to know one. So I can run the summary, $, and $sign follows the column name. This is how you access the columns in the data set, okay? So this is gonna show the summary just for that column. Another way to show the summary, you can run lapply. Lapply is gonna apply the function, the specified function to all columns. Like here, I specify HR data, right? And I want to run the summary on each command, on each column, a command at a time. So see this? A column at a time. Do you see this? Those are my columns, and those are their properties, right? If you will. Apply, and this is running the summary for all of them. And another thing to note is that Here it shows all departments. That's another difference. Here you see all departments. It's not grouping anything into category other, right? So this is something you may want to use if you have something with more values that actually summary command can show. Or you can use this parameter too. Okay. Now I have a lot of statistics here, but I can show just one at a time. For example, if I want to see just the minimum, I can run the minimum command. Or if I want to know the range, which is minimum and maximum, I can do this. So here is the standard deviation SD, which is not part of the six number summary. Unique command is going to return the list of unique values. So I'm going to click on here. Do you see this? So those are the same levels command return the same thing. So the levels of the categorical column, right? The levels are the values that the column may take into, right? Now here, I can also, if I want to show the maximum, this is going to show the maximum satisfaction level by department, right? Maximum satisfaction by department. Now we're going to talk about the subset. What's a subset? We want to output first 5 rows in here and all variables, right? So basically the subset is this. Well, let's look at this one first. This, what it does, it returns the first 5 rows and the first 3 columns. So here you specify the column position, and after comma, you're going to specify, well, here you specify the rows, sorry, first 5 rows, and 1, 2, 3, those are the column positions that you want to return. If the columns are omitted, then it's going to output all columns. Here, in this case, you're going to show the first 5 rows, right, and all columns in the data, okay? Now here, it's just going to show 5 rows, 3 columns. Here, this is another way to do it, but it's getting the list of column names. So here, you can do that. Here, suppose that I want only column 1, 4, and 5. I can use combine command and I can list the columns that I want to see. So let's just run this. Oops, did I run it? Yes, I did. Those also the columns, that's a positional, right? You could also name the column. You can do it by name, department and left, right? Okay, because sometimes you know the column name, but you're not sure the position in that, right? And what this will do is it's going to return all rows and 2 columns. I can run it because I wanted to show you what happens. Do you see this? Do you see this? It's emitted a lot of output. So how does it know where to stop? It's one of the settings, right? There is a settings where you set when you reach the maximum allowed output, okay? Now, I did that. So this one is where you explicitly specify the department. This one is, well, this is a column salary, and I want to see the first 4 values. But remember, salary is a column, right? So that's why I put a $sign. Okay, let's see. Let me see. Come on, run. Oh, okay. So what I'm doing here is this one, it just shows the salary at the first 4. The first 4. See this? It shows this way. Low, medium, medium, low. Okay. Now here, I can specify that I want to take a subset of data where the salary is medium and I want all columns. Either this is a conditional, is specified, right? You specify that the salary must be at least at medium, right? So I'm gonna run this thing here. Okay. Everything should be medium. If the salary is high or low, it was filtered out, right? I can have more than one condition. So this is the end. I want to say department is HR and the salary is medium, right? I could do that. Now, sometimes you may need to do some calculation. You may need to add a column. To add a column, you just put here is HR, right? You put a $sign followed by the name of new column, And here you just specify what you want it to be equal to. Like for example, the time spent in years. For example, suppose that I want to know how many months somebody spent, right? So I can just go number of years times 12. Let's try that here. Just for the purpose of this example. I added this month spent. What I need to do now, I need to verify that things went as I want. So see here, this is a 36 rows, right? And time spent is 3. 3 years, it means what? 36 months, and etc. I would probably want to check some of them. Now, we no longer need the month spent column. You can delete the column by setting it to null. Easy, right? Now we need to run the head command again. We need to verify that the column was deleted, okay? Next topic is sorting. Why do we sort? Sometimes sorting helps us identify top 5 perhaps, right? For example, what are the top 5 satisfaction scores? What are the top 5 salaries? Something like that, right? So this is what we do, the order, see? So this is the order you're sorting by the satisfaction level, right? So that's a column you use to sort, and then you select in all columns. So let me run this one quickly. Okay, so I created this one, right? I created this one. So we need to look at that. Okay. So yeah, it's gonna be long, but this, I just created this, right? Now, next thing is you can check the first 10, right? Oh, here, HR sorted. You can also sort it descending. To sort it descending, you would need to put a minus sign in here. Okay? To sort descending, we put a minus sign right before the data frame name. All right, and you may also sort by multiple columns. So that's an example of sorting by multiple columns here. Oops, what did I do? I did something. Oh, I see what I did. I accidentally unpinned this tab. Okay, now, well, this here just gonna show the first 10 rows in HR sorted. Right, so here I can do this, I can sort like this, and here it's gonna show me the 10 rows, okay? That's what it did. Factor variable. We have a column here that stores if an employee stayed or left. That column can have only 2 values, right? Stayed and left. For some reason, R did not recognize that this is the factor variable, right? Because it just reads 1 and 0 from the input file. What we could do is that we could convert that to the factor. So see this, what I'm doing here, I'm reassigning the column to itself, right? And I'm making it factor. Okay. So then if I run my statistics again, I'm expected to see the distinct values. I'm expected to see the distinct values. See this? So this is a 0 and this is a 1, right? Because for the factors, I'm showing how many instances have each value. And each factor is going to check if the column is a factor. Now, next topic is going to be the frequency counts. Table command is going to return the frequency count, right? Well, this one is going to return the percentage. So this is a percentage of the high salary, low salary, and medium, right? Okay, next thing is the missing values. So remember this, some functions don't work well on the missing values because see, we have a column called last evaluation. And if right now at this moment, I'm gonna take the mean, right? I want to know that on average, when was the last evaluation? and I'm gonna get NA. Why did I get NA? Because I have some instances, right? I have some evaluations that are missing this value in this column, okay? So the way to do that is to use this option, and ARM equals true, right? So if you use this option, then it will ignore the missing values. That's one way, right? Well, however, we want something like a more long-term solution, right? So now let's check how to identify missing values first, and then we talk about handling them. Okay, so here is NA. It's going to return 1 if it's missing, right? If missing. And it's going to return 0 if not missing, right? So we need to figure out now if the data has any. I'm doing in here. I'm running any here. If any of these, if any of the checks returns that it's missing, then it's missing, right? Is this one is any? Let's see. It's supposed to return true right now. Yes, because I don't have. Well, I have missing values, right? That's why it returned true. Because I have some columns with missing values. So let's do this now. Let's do the sum like this. Okay, so I'm gonna run this. The sum like this, right? It's gonna tell me how many columns I have missing. How many values, sorry, total number of values that I have missing. It does not tell us information on which column, right? It only tells me what is missing. So, and here, HR last evaluation, right? So let's see, let's do this run. Okay. Oh, I ran the wrong thing. Okay, here it is. Last evaluation. Why is it jumping? Okay, so because I ran last evaluation now, right? Oops. And I checked. Basically, it should return that I have missing values. Okay, I have missing values. There we go. Oh wait, this one returns how many is not missing. Oh, wait, hold on. Okay, so here, take a look at this. Sum, right? It's gonna list the call. It's gonna list how many instances are missing this value, last evaluation rating. So we need to know how many instances are missing the value in this column. So we take a sum, right? Because here the evaluation is this will be evaluated to what? To 0, right? Well, because if there are no values. And here we were going to find this also when we run when we check other columns. But here, this is the display observation if at least one variable is missing a value. Display an observation where at least one variable is missing the value. So you want to run the not complete cases command, right? Not complete. This is the command to run to display the list of columns with missing values, right? So let's do that again. Where is okay. Oops. Now, so here, well, if you run this as a command, run it. Well, okay, this one we did it. Here, I want to know who is missing last evaluation, right? So I can do that. Well, this is a row number, okay? Row number of person who's missing the last evaluation. Now here, this is, see, not complete cases, right? It's taken the HR and it's taken the incomplete cases. An incomplete that has at least an incomplete test has at least one. An incomplete. If it's incomplete, there should be at least one row. Okay. So let's see. Let's do run. Call. Okay. So now let's see. How do we handle missing values? There are several ways. One way is to set the column with a column minimum or maximum, whatever you want to do. Another way to handle missing values is to impute them, right? Like for instance, I can set it to the class average grade, right? And another one is ignore. Well, but it depends on the problem that you're trying to solve, okay? Some methods handle missing values, some methods do not, so, okay? Now in here, it's just handling missing values by setting the, it's gonna set this, so it's here, right? Sorting, we did sorting. Okay, the missing values. Jesus is here, it's columns is an A. It's gonna do how many instances are missing a value for each variable, right? The number of instances missing for a value for each variable. Okay. Now, okay, so let's move on. Okay, well, this one, it will show the observation if at least one variable missing a value. Okay. Okay, so now we're gonna do handling missing values, and another way to handle missing values is to set the column to the column average. So what we are doing in here, mean HR last evaluation, it's picking up the average last evaluation. We have to have an ARM equals true. Why? Because you want this calculation to ignore the missing values, right? So this one, HR last evaluation, right? That's a column name. And you say an ARM equals true. That will make sure that you're removing the missing values. Now here, I can decide to use a predefined value. For example, if this average something missing, right? By default, it's just gonna set to 200. That's what it does. You can do that. Now here, this just does, it just return the summary after we did all of the pre-processing. But I guess in order to keep the same file, same data as me, I had to run it, right? I had to run the code. But here, take a look at this. This one is returns is an A, which means if value is null, right? So hold on. Okay, so this is one is an A. So let's see what it does here, right? So see this, it just shows if any of the column has any of the missing values. No, nothing does. Okay. Now here, this is important because for next assignment, you're gonna be loading one package. You're gonna be using a rules package. Actually, maybe two, because a rules visualization. Okay. So what you will need to do is, if you haven't already, you would need to install package rules. Okay. You go up to the install packages. Okay. Okay. This is the command here. It will remove from memory, and will remove permanently. But we need to look at the positive commands, right? Commands that will help us. Detach package. Okay. So yeah. Basically here, well, I just showed you we're gonna get to plot soon, but I showed you just how to install the package, right? You're gonna need to do this. You're gonna run install.packages, and in a double quote, you're gonna put the package that you want to install. packages are just sets of functions, right? And there are some packages that were pre-installed and some packages that are user. User means that you installed them from current repository and from another source, but they were not there at the time when you launch R for the first time, right? Next one is update package. You have to update packages regularly because as we speak, somebody making changes, right? All right. So next one, this is how to remove the package of straight. This one is how to remove the package from the person, and the other one is okay. So here, oops, let's come back. Let's come back. So here, well, this is a package that you're gonna install, right? Now I'm not gonna run it because I already installed it, right? But now we're gonna go to data visualizations. Most of you by now know how to run the histogram command, right? Well, so here, what I'm doing is that I'm doing average monthly hours, and I'm just gonna do this, okay? Well, this produces a histogram, but I'm not limited to this. What I could do is I can change the number of breaks. I can change my color. I can change input hours and the color, right? Monthly hours, sorry, and the color. Then you may use multiple input parameters, right? So something like this, it's gonna be something like that, right? So, well, remember this, that you can add parameters. And if you don't know which arguments you can specify, you can always do what? Read the help page, right? You can always read the help page for the command. Now, in here, what we are doing is we're creating the variable called salary T, and we are setting it to the frequency count of the salary, right? So it's gonna be salary and number of people who have that salary. Let me see. Okay, run. All right, and here let's display just this one. Okay, I've got the 3 columns, so far so good. Next one, here, this is the bar plot, this is the visualizations, right? Like for example, here, Jesus, and you just add, it's a customization, you just need to add, Jesus, you can customize the function, you can add the title, and you can label the x-axis and the y-axis, okay? So if I ask you how to add the title, it's a fair game, right? This is what you're gonna do. You're gonna go here, you're gonna type the question mark, and you're gonna do and you're gonna paste this. Control V. Like for example, a rules visualization. Oh, right now it says no, it says no the documentations because the package is unavailable until I load it in memory. Okay, the package is not available. I have to load it in memory. So here are my packages, right? I need to load it in memory. Then I'll be able to. Now, look here. This is in red. Are those the errors? No, those are the warnings. What it's telling here is that there are some dependencies. A rules with package has some dependencies. So, and some of the dependencies have a function with the same name, right? So that's why you're getting this sometimes. Well, some messages are informative, let's say. This is not an error, okay? But just be aware. Now, what I did was see to now I can rerun the command to get the help. Oops, still no. Oh, because I had to put the package in the memory. I forgot that I need to do. I have to put this. I have to do where is it, download packages, right? And then after I put the package in the memory, I need to run the library command. And also, this command is case sensitive. I have to make sure that I spell it correctly, correct capitalization, right? See here, it did not recognize my rules with package because what I did was I did not spell it correctly. So how do we fix it? We need to go back to the code, right? And it's in install packages command. Okay, so I'm scrolling down. Okay, this one. Yes, it's this one, I think. Yeah. Okay. Well, and then now if I run it, then it will go, the library is going to be in memory. When the library is memory, it's available and we can use it, right? We can use it by our code. Okay. Next one. So we talked about the uploading and removing packages. Next one is going to be the data visualizations. So probably most of you are sick from the histogram right now, right? It just shows you how to change the parameters. But now, since most of you see the histograms, right, you probably know what I'm talking about. And this is going to be the advanced one, more advanced. Oops, removing packages. Okay, I would have to look into it because it was working before. Oh, there we go, it works now. Okay, so this is another histogram. Okay. Now, bar plot. Bar plot is another one. Let me see, right? And then in here, I can also, oops, okay. What this does is that it computes the table of salaries. It's gonna do the salary level and number of people at each level, right? That's what I just output. But why don't we do this, do something like, let's see what happens. I'm gonna run this command. Now, this one is bars. We want the bars to be ordered, ascending or horizontal. So see this is a visualization here. Next thing, what I'm doing is that I'm going to show that it's not overall work. It only works for people who listen to Elena, right? So let's see, right? So this works, right? So now, this one, I want to do the sorting. Oops, this one here. That works, right? That works. Okay, so that was the horizontal bar plot, horizontally oriented. Pie chart. Pie chart could be very difficult to read as the number of values grows. Basically, it turns into a clutter, right? Okay, so it's in here. Oops. Yeah, so I want to see the salary, for example. Well, here we are fine because our only values are low, medium, high, right? Only 3. And it checks basically the higher is the slice, the more people you have, right? The more applicable is this value, right? Like, for example, it shows most of the population are with a low income, right? Low or no income. Now, the visualizations that you choose depends carefully on the data type, right? So here is the box plot. Let me run here. This is a box plot, right? Familiar? Should be, right? Now, we did the box plot. Now we just do generic plot. Just single character in a file, right? So that worked, right? HR, somewhere I saw it. So let's see, let's try it again. Oh, well, here what we need to do is we want to plot HR and salary. You want to plot the salary only. Let's see. See, it did not quite work as well. But now I want to put the salary and the department. Let's see what happens. See this? So this is salary and the department together. And here I want to check my average monthly hours, right? My average monthly hours. Okay, now, so we did that, and this one is, there are two numerical variables, right? So let's see, let's do run. And they see, there are two numerical, so they need to know which one, right? Oops. Okay, so yeah. For numeric, see bar plot, it takes bar plot, right? It's gonna take a frequency table as an input, or you can do it on the fly. Box plot for numeric columns. Plot function, it could work for the single categorical, and you can use for the, you need to have at least, you can use the numeric columns, right? Okay. So in here, you've got two categorical variables. All right. So here, let me see what's going to happen. This is a type L. It means it should be showing as a line chart, right? Ooh, what's happening? So I go this salary and run. Oh, it's because, oh, here we go. Well, see this, it works. And it works really well. Now, okay. So see this? The default behavior, and this one, I'm gonna take this, those are the two numeric, I think. Yes, I'm gonna just go ahead and I'm just gonna run them to make sure that everyone's work runs, right? Okay. So type 1 is an optional parameter. It specifies if you want to do, how you want to plot, in other words, right? If you want to be single categorical able, or perhaps you can do it once a day, etc. Right? Okay, so let's see. Plot HR salary. Yes, it depends on how much data you have. So let's see, let's do run this one. Run. See, this is fine so far, but sometimes it depends on the data type. See, like if you're looking at something like that's happening daily, for instance, right? You could have very large, so some visualizations might not work as well on a large data set. Like pie chart is an example, right? It's going to be cluttered. And see this one, it's cluttered. And this is two variables, it's going to be cluttered too. So what you would need to do is you would need to do some pre-processing to actually visualize it, right? See, this is not readable, so you need to really choose carefully the plots. Like, see, like pie chart, it's not suitable for many categories, right? It works well here because I just used 3. Okay, so let me see. Can you color it? Yes, you can color it. Yes, you can color it. So how do, oh, okay. What is it? Does a list? Yeah, list always starts at position 1. In general, list starts at position 1. Can you color? Yes, you can color, but which one do you want to color? Which one? The let's see. You want to color
I
box
was just
plot?
thinking the histogram.
The histogram?
Yeah, you're in
Oh,
3 dimensions here, right?
for the histogram? This is,
The chart you have on the lower right,
oh,
if
this
that
one?
were shaded, yeah, if that were colored, would the data be more understandable?
This is not the histogram. This is just a generic plot function. That's why it's a generic plot. We
Got
would need to, yeah, yes, it's a generic plot. So see, this does not work well sometimes. What I'm trying to say does not work well. But this one, this works well. That's a line chart. Salary, right? It's a line chart that work well. But in here, see for the two columns, well, it did not work well in here. It depends on the number of data points. It depends on too many things. Okay. And also it depends on if it's if two columns are correlated to, right? It will show differently. So let me see. Let me run this again. Oops. Yeah. See this? What I could also try to do this zoom to open it bigger. Oh, now you can see more. If you open it bigger, you kind of like see more like dense areas and sparse areas. Yeah. Okay, so the plot you select depends on what you are actually doing. So here as a slide, I'm gonna let you have this copy, right? Those are basically the notes. As I was doing something, I took notes and I'll let you have them. Thus, we talked about the environment, right? We talked about the environmental window. The environment and window can have two views, right? The grid view and the list view, right? Well, one thing about the grid view, what I like is that it can give you the size. Well, especially if you are working, this is a desktop version, but at some point in Data 650, if you're gonna be working with our version that is on a cloud, right? Our version on the cloud, then you probably would be paying attention to the data size, how large an object is, etc. Right? So everything is a vector. Remember, we talked about it. We talked about help system. We talked about the history of the commands. We talked about working directory. What else we have not talked about? Okay, this is how to preview the data, right? So data frame structure, properties, we talked about that. We talked about the subsets, right? So now sometimes people ask why we delete the column. Sometimes unique identifier could be deleted because it's irrelevant to analysis themselves, and it could slow down the algorithm, slow down the methods such as neural network, right? Sometimes the data could have sensitive information. For example, I don't want my social security to be part of analysis. I would rather have it removed, right? My first name, last name, that should be removed. Suppose that I have the column that has the same value for all rows. Like for example, state, country, United States, right? All data is about US. I can just drop that column, right? You can, anything that you decided not to use, it will reduce storage consumption. Or for example, another reason is I could have the column where most of the values are missing. There is no inside, right? Something like that. This is just an example when you would remove. Another example could be the skewness. Like for example, suppose that I have only 3 people from Canada and everybody else is in US. I don't have enough Canada data, right? So I could just ignore that column. Well, this is just descriptive statistics. Nice summary about the sorting and why it's useful, right? You can do the top 5 perhaps, and also for duplicate detection, right? To identify the duplicate rows, you sort and duplicates will be next to each other. Those we talked about these commands, right? And we talked about the missing values, right? We talked about a lot about the packages. Rules, it's gonna be the package that you used probably in an exercise. The cars exercise, you do the discretization. And also next week you'll use that. Those are just the comments, different comments you can do with packages. And then I summarized, I put a summary when each chart is suitable and when each chart is not suitable, right? So, but mostly if it's large data set, right? You probably want a histogram, but histogram shows the distribution of values. It does not show the actual values. So remember that the histogram shows the values distribution. It does not show the actual values. And pie chart just also shows the frequency, but more like it's like a relative frequency. See this? Right? And there's different, this was what we looked at, the generic XY plots, right? So it's a scatter plot. You use it to show relationship between two numerical variables. And as you just saw, they're not really visual appealing, right? When you have the large range of data, they don't look that nice. Okay. And how to exit RStudio, you're gonna run which command? Q. Q command is to exit RStudio. And then, well, there are two files. Well, and there are two files. R data, it contains the objects that you have in the memory now. And R history is a history of commands. Those two files could be saved. If you select save, then those two files will be saved as part of the R workspace. Next time you just launch R and you will see that. You will see the environmental variables, right? Because it will be saved in here. Now, our next thing, those are the courses after this class. After this class, if you will be interested in learning R in more depth, right, and you'll need it for data 650, you can go to Cognitive class site, and there are some free courses that you could look at. Well, there are a lot of materials in the classroom though, but those are good too. Then we have a LinkedIn groups, couple LinkedIn groups that you can join, and sometimes they provide interesting articles. So I would recommend, I'm a member of both groups. Those are just some packages that you may, some pages that you may want to bookmark, some available grant packages, some frequent question and answers. Then you may join the RStudio community, right? And etc. So just reference. I have to list some references because I didn't make up the presentation content, right? I had to use some references to come up with presentation, so I need to put the references. Okay. Now let me see if anybody in the audience has questions. Is it, guys, clear what you need to do for your assignments? Okay, let me see the chat. Oh, okay, most welcome, yes. Okay, so basically, the way it works is that you have ungraded exercises, but some of you are gonna say, hey, ungraded, I don't need to do that. No, not true, because your quiz is gonna have the questions on those exercises, and you learn from it, and then you do the assignments, right? And a quiz, well, you got 3 attempts, so, you know, if you answer the question wrong, if you know which answer is wrong, it helps you to know which answer is right. And remember that when you repeat, you may see different questions. So when you take the quiz again, you may see questions that you didn't see before, and the questions will be in different order, and also the order of the answer choices, random. So you cannot tell your friend, hey, I answered question number 1, the correct answer is B, because the question number 1 could be different, and the answer choices are shuffled too. So you cannot give the answers to your classmate, in other words. There is no easy way to do it. Okay? So, more questions? No? Questions? Then here is the deal. You're gonna have the recording of this presentation. You're gonna have the slides. I'm gonna give you the R code and the file, because if you want to follow along, right? If you want to follow along, what you'll need to do is on your hard drive, create folder called data sets, right? The same spelling as I spell in the code, and put that CSV file in that folder, right? So that way you will be able to reproduce the output that I showed you today. Sometimes some people prefer doing it along, following along and watching the session, right? And also I wanted to tell you that you may need to watch portions of this session more than once. That's how people learn, right? So you may need to watch certain pieces of this presentation more than once, okay? So if there are no questions, then I'm gonna call it a day, and I hope you guys enjoy the course. Oh, let me see. Oh, most welcome, most welcome, most welcome. I tried to cover as much as I could, okay? So, okay, so what I'm gonna do, oh, how do we get the script? I'm gonna give the script to instructor, and the instructor is gonna post it in the classroom somewhere, okay? So you're gonna get everything, no worries. Okay, so I'm gonna stop the recording. Stop recording. Okay.